break the ice, showing what we're going to do. Again, I will screen my whole screen and I recap. We have a repository. So in case we will arrive at some point that either the instructor, the audience, or the time are exhausted, and you will be able to continue and to try to practice yourself with the code that is in the repository. So we will see how to use it right now. There is also the companion website, and thanks for reporting the errors. I will try to fix them immediately after the practical. And let's start with checking that Nextflow is actually installed in your VM. So we can run Nextflow -version. And we already can learn something about Nextflow from this command. The first thing is that it takes long to start, but then it's going to be very efficient to do everything else. And the second is that Nextflow itself is the command that we are running, but then we are feeding to Nextflow our script, our pipeline. So there are two kinds of parameters. The parameters that are directed to Nextflow and the parameters for our pipeline. And to avoid conflicts, the brilliant solution was to decide that parameters for Nextflow start with a single dash -version. And parameters for our workflow, they will start with 2 dashes. So there is no possible conflict. We can have -version for our pipeline, and that will not collide with Nextflow version. So the version is year, month, and release. We have a very recent build in the VM, which is great. And it's great because we're going to use DSL2. So if you have a very old version, you might need to update it. And the way we can update or change version in Nextflow is quite smart. So there is a system, an environment variable, an fx var. And if you set it to something else, like 2004, Nextflow will use that version. And if it's not installed in your system, you don't need to do this in your VM, of course, we'll download the version that is missing and required. And in this case, it didn't work. Maybe I made a typo. Nextflow. Okay, of course, I invented a version that is not existing, but this is the point. So we already have what we need, 21.1.10.0. So let's try to update it a bit. Let's see if that works. Yes, I know this because it's the one that I use in my machine. So 21.10.1 is an updated release. And because I specified with export nxf_var a version that is not available locally, first Nextflow will fetch the version that is required, and then we'll run using honoring the system, the environment variable. So now we have 21.10.1. No big deal. So let's start creating the very first script then. So we can create a directory. And let's create a hello world script, as every programmer does. So nano hello.nf. You can use the editor you like the most. Nano is quite simple and usually available in every machine. So as I said, the first thing we need to do is to be able to receive some kind of inputs from the user. And I said that there is this params structure that will receive things from the command line. So everything that is double dashed will be put there. The comments are double slash. So I will initialize name with my name. And I will not initialize the surname with a value. I see that there is a strike of VMs. Thankfully mine works, but of course it's nice. It's also yours will work. So while we check into that, just have a look at this simple example. I will use the print line statement, and I will hard code hello. Class params name.
You got a typo, I think, Andrea. Should be both param. Should be both params.
Yes.
Thanks to everyone for spotting that.
Thank you. It's only me having lazy double quotes with this terminal, or? Okay. So here we print hello, and then whatever it's inside param's name and whatever it's in param's surname, and an exclamation mark at the end of it. We have our comment here, and here we initialize params.name with something, and param.surname is just false, so it's not getting any string. We will see what this means. Now I save this. We have the script saved as hello.nf, and to run a script, the command is nextflow run. And as we saw in the slides, this can be something that not necessarily is a local file, but in this case would be hello.nf. And I run it without any other parameters. So like this.
So are we meant to be following along with you or following the tutorial?
I think we can do both. So people that are more adventurous can easily follow the hands out, and who wants a more gentle introduction can follow me. And in any case, feel free to ask questions. I wanted also to have some feedback on the VM status. Are they up and running now?
Why is yours stuck?
Is it? No.
Oh, there you go. Okay.
It's slow.
Tank seems to have disappeared, so I'm guessing he is feverishly trying to pull it back together. You're false. Oh,
Yes.
Okay.
So without giving any parameter, param's name is substituted with the actual string here, and of course param's surname is rendered as the boolean that we put here. The pattern that I'd like to introduce is that if you are expecting parameters, either you initialize them as a default, which is a very good idea, or if it's not possible, at least set them as false so that you can handle the case better with some input checking at the beginning. Because the point is, now I can change name with Nabil, but I can also feed any other parameter like institute QIB, but because there is no use of params inst, this is sort of an anti-pattern. So it's better to declare in our script what are the expected parameters, also for a better documentation of the code. When you run the pipeline, each single execution receive a random nickname, like Modest Newton or Happy Euclid. You can specify a name with minus name, because as I said, minus something is a parameter for Nextflow, while minus minus are for your script. But if you run the pipeline twice, you will get an error, because you can have you cannot have multiple executions with the same label. So just leaving it out blank will allow Nextflow to pick a random unique nickname. As you might guess, we can simply pass surname here. How many errors did spelling errors I did here? Nabil. Apologies for that.
My name is fine.
Okay. Okay. Now we are ready to do some more serious stuff. But as I said, this would be probably similar to a nasty math lesson where you spend 20 minutes on the first thing and then, okay, QED and everything is up to you. But I think that the first steps are the hardest. And if you get lost here, you will find it difficult to follow the tutorial on your time, at your pace, while probably with a gentle introduction, you will be more likely to be able to follow along the instructions. So if you have a look at assembly._0, the script itself is not going to do anything. There is no process and no workflow, but it's just some comments. And this directive is to enable DSL2. We're going to use DSL2, so we will need this in our scripts. Then we specify the parameters that we're going to use. Now, our real pipeline will require two parameters. Reads, the directory with the input reads, and out there, the directory where to print where to store the output. Only for assembly 0, because it's a script that is playing around with these parameters thing, we have a special thing called params collect that allows us to play with channels, and I will show you how. So Nextflow, to create a file channel, require this pattern where we have wildcards. And either you have a single wildcard, and in that case will be a single end channel, or a single files channel, can be any kind of files, of course, not necessarily NGS files. For paired end, you need another part that is these brackets, forward tag, reverse tag. Okay, so there is a problem, a generalized problem in our training VMs. So I will just go slowly and show you how to run this assembly 0, and then you can just skip it because it's not going to do anything else, but you can use it as a template to be modified and to play around with. So this script is not very user-friendly. Usually you want to feed to the script the directory, but we will expose how Nextflow works, asking the user to give us as reads a pattern that contains the directory and the pattern to discriminate between forward and reverse. So here we create our first channel. So channel dot from file pairs, and then we feed the reads parameter and we check that the file exists. So this is a good pattern. And remember that if you have a directory, for example, where you have files called something underscore 1 or 2 without the R, this pattern will not work. So you need to change it here. As I said, this is quite a bare script, so it's not going to be probably incredibly user-friendly, but it can be improved, of course. So here we have a typical if-else statement. So if params collect is true, so if the user specify minus collect, we will see how collect works using the view operator to see the content of the channel. Otherwise, we'll just see the reads channel without any modification. So in this case, we had both collect and map. But again, you can play with the script and change it. But we can have a look. Okay, this didn't work as I expected. Slightly better, but not as I expected. But I would say at this point, let's clone the repository. It's exactly what the repository is made for.
Yeah, I think best if everyone just does that. Just
So
clone the repo.
Copy the, so if you click on code, you can copy the repository address and then clone. Let me see if this works. No. Ooh. Okay. Right.
You can't access your own repo, I think.
Yeah, I didn't configure the VM, of course, to do that. Clone. Please use the Discord chat for commands so that it's easier for others to copy the correct command. So now we cloned the repository, and if you do an ls, you will see that you have a new Nextflow example directory. You can cd into it. We have all the scripts, and we can make copies so that we can edit them without feeling guilty. So if we want to make copies, we can just cp assembly 0 to de novo 0, for example. But this is only if you plan to modify it. So let's try to run this one. Nextflow run dm0 without any parameters, and we'll see what happens. So let's see if you can guess without seeing my terminal. So what happens in this script is that we receive, or at least we initialize two variables, params reads and params out there. But we then use this string, this pattern, to create a channel from files. So if the files do not exist, something will happen here. Should probably use a different VM for this. And then either we supply minus minus collect or not. So minus params collect will be either true or false. And without minus minus collect, we would simply print the content of the read channel to see how a channel is rendered. And if collect is true, we will use this pattern that we presented in the slides that consists of two things. First, we remove the keys. So when you create a 5 pairs channel, it's stored as a tuple where the star part is the sample ID, and then you have the two files, forward and reverse. So as you can see, no files, match pattern, star, etc. We don't have data in our repository, and this is of course good, but we can get it. So if you run bash get data, you will download the small data set that I used.
So how's everyone doing? Just put in the Discord chat if you are still having any problems. Should hopefully be back on your VM and able to follow along.
To recap, when your VM resurrects, clone the repository. The command is in the channel, then enter the directory. So cd Nextflow example, and bash get data.sh to download the dataset. I pasted the commands there. With get data, you just download 3 small datasets in your data subdirectory. So this will make the next test work. If you want to make your life easier, you can remove at least one file. I will remove the phage T7. And I will just use 2 samples. And of course, making small data sets is an art for pipeline development. It's really a good thing to do. Now, don't worry too much if you have issues with your VM, because after the workshop, you are less likely to work at the same time, and so probably you will have a smoother experience. And I will release full screencasts of everything, even slightly different from the live, so with less pauses. Now I can run again the workflow, so dn0 or assembly 0. In this case, the difference is that it will find the data directory, and the files in the data directory will match the pattern. And so something will happen. So Jake, what's the error that bash get data is giving to you? Is like file not found or something different? You should be inside the repository. So after you clone Nextflow example, you should cd Nextflow example to enter the directory. And so this is quite complicated, but now we are seeing our first channel. So if you can have a look at the Zoom screen, it's a good moment to do so. Our pipeline was executed. This is Nextflow telling us its version, the file it's executing, the nickname for the execution, and then from now on is our script telling something. So we print to the user the input that we received. It's good for the bug. And then the command that is executed is reads.view. After we create the reads channel, because the pattern exists, the reads channel is created. So we are here. And as you can see, we have this set of tuples where the first element is the string, the ID. So whatever is before R1, before the underscore, this is the ID. And then we have a list of files, in this case, of forward and reverse. You will see the documentation of Nextflow is quite complete. Of course, the most common example of this pattern is for paired end files. But the same command can be used even if you have triplets. For example, you have forward, reverse, and long reads. You can use changing the number of files expected. So you can say, I expect 3 files with this pattern. Or when things became more complicated, probably you will want to create a sample sheet with different columns with different files. And you can make more complex pipelines. But dealing with paired end is really something that is quite common. So it's a good pattern to have at hand. And as you can see, we have 2 elements in our queue, this one and this one. Now we'll try to rerun it with --collect to see what happens if we first remove the keys and then we use the collect operator. With this script, you already cover a good 20% of what you need to know for a Nextflow script, because getting input from the user is really important. And we are also peeking into channels, which is also very good for debugging. So compare now the rendering of the channels. Here we have in brackets every element of the channel. So here you have the first here and the second here. And also inside here we have the forward and reverse as 2 elements of a list. But the point is that we have as many elements in our channel as the samples are. Here we have a single element. So the channel that we created with the collect operator has only 1 item. So if we attach a process to that channel, so if a process use that channel as input, will be run once, and the only time it will run, we'll get all the files forward and reverse from all the samples. Is this clear? Can you give me some feedback about this? Because this is quite an important part. Good. Okay, now we can start the serious stuff. So we can, okay. Feel free to unmute yourself and just share what's difficult.
Just remember that Andrea renamed the Nextflow file just so that he'd have his own copy to work with. So if you didn't do that, it's going to the repository is originally called assembly_0.nf.
Yes, absolutely. So to recap, list the files that you have here, or you can have a look at the repository. And there are some, let's say that you will see how the pipeline is built, moving from one script to the other. The first script is assembly 0. And if you want to experiment with it, you can make a copy. I call it DN0 as de novo for short, because it's it makes you free to make errors and have the working copy in the same directory. You don't need to do that, but I would recommend that you start playing with the scripts to have a feeling of what happens.
Where can I see the first steps after the version command? I'm not sure I follow.
Well, the first steps were basically introducing these params parts. So if you have assembly 0 in your file system somewhere, so if you clone the repository, now we are in assembly 0, and assembly 0 is basically playing with params.something. And something is what you pass through the command line. So if I execute the script with --collect, Nextflow will set params.collect to true. And if I execute the script, changing --reads to something else, this default value will be overwritten. This is what we were doing after the version command, nothing more. So the take-home message of assembly 0 is we have a way to receive input from the user. We have a way of letting the user telling us which files to analyze. It's, as I said, it's not user-friendly, but it's from a tutorial point of view, it's the way Nextflow creates the channel. So if we want to change directory, let's make an example. So I copy the data directory. Now I have an input directory and I want to analyze that. I need to specify a different --reads parameter that can be --reads. And we go to a new line, --reads. So if you're not familiar with multi-line commands with a backslash, I can go to a new line. And the prompt will change to a greater than that you don't need to copy. It's bash giving you a hint that it's expecting more. So absolutely do not copy that. And now I can write something similar. I just changed the directory. Let's see. So --collect will switch params.collect to true. and minus reads will pass this string to params.reads, and we will make use of that string to create a channel here. We'll create a channel from file pairs, and to create a channel from file pairs, you will need a pattern exactly like this with a star that will become substitute the sample ID, and then you need a pattern expansion that only has two options, so either 1 and 2 or 4 and rev, something that we use to flag the forward and reverse files. So because in our pipeline, sometimes we have modules that for each input will create a new process. So for each input file, we'll have a filtered output file. For each filtered pair, we'll have a config file. So when the relationship is one-on-one, we need just the channel as we created it. Sometimes in steps like quast or summary for abricate, we need to collect all the previous execution. And the pattern to do that is collect. So with this assembly 0, we just experiment the effect of using or not using collect, and in this case also with map to remove the sample ID. So to show the difference between this and this, we created artificially a script that will allow us to either use or not use this this function. So you can do similar scripts to experiment yourself different scenarios. For example, you can remove the map and just use the collect and see what happens. So consider this tutorial as seeing where to go, but of course, Nextflow website and tutorials, and there are some links at the bottom of the repository as well. So learning Nextflow in 2022 is a blog post with different links. This is a tutorial, and well, this is from MultiQC. So of course, if you really want to get into it, you will need to sit and go through part of the syntax. But this, of course, it's something that we can cover. We cannot see all the operators, and we can do a formal introduction, but we can hopefully give you the idea of how Nextflow works and how we can use it. Okay, now I changed the reads, and indeed, in our feedback here, we see that it's going to get the reads from input. The output doesn't change really because I copied the directory, but you can see that the paths are different. Now that we can handle channels, they will become probably a bit clearer when we start to use them. And so let's see what assembly 1 does. In assembly 1, we have the same start of the script. So we enable the new syntax, the SL2. We still need 2 parameters, the input reads and the output reads. We create the same channel. We do not have the collect collect flag because that was just a toy example. That's why it was assembly 0 rather than assembly, because it was not meant to be built on top of that. It was just a first playground for parameters. Then we print the parameters that we received from the user. Know that here we use triple quotes to have multi-line text. This is also something that can be interesting. And now we have the workflow. And we have a workflow that uses 3 processes. And so we will need to define the 3 processes. But once you define the first, it's going to be very easy to define the others. So our workflow, I write it at the end, but you can write it also at the top if you prefer. But more importantly, if you have the question, can I write it, the workflow at the beginning? Just experiment, make a copy, move the lines on the top and see if it's going to be accepted by Nextflow. So here we drafted the simple workflow where we have FastP that will filter the reads. Then we have an assembly step that will take the output reads from FastP. And then we have Proca that will take the output from assembly. So let's go a bit deeper. I already mentioned it briefly before. But when you execute a process, you implicitly have fastp.out, so process name.out that contains the output channel. If you only have one output, that's enough. But to make it clearer, you can name the output channels. So in the case of FastP, we created a FastP reads output channel, so FastP out and then .reads, while for assembly, it's simply assembly.out. Let's see what this means, starting from FastP. So the workflow requires a FastP process, and FastP process is going to receive one channel, the reads channel. The structure of a process is at least to have input, output, and a script area. So input and output will have as many lines as the channels they respectively get as input and emit as output. So FastP will receive one channel as input, that is the channel that we created from the string that the users sent us. So it's the paired end channel. And that channel we saw from the terminal without collect, how it's structured. So this output was using the collect operator, but in this case, we are using the reads channel as it is. And this means that it's a queue of samples. So every item of the reads channel will be one sample. And every sample will be structured as a tuple, as we're going to see. And it's important to know how the channel is structured, because that's what the process will receive. That's why .view can help us understanding better how things go. So if you check the documentation of channel from 5 pairs, you will see that by default, he will expect 2 items. That's why pairs. And what it's going to do is that the first part of the name is going to become the sample ID, or at least it will be stored as a value, as a string. So here we have GCA 0099 something. This is the value. And then we have a list with the 2 files, the forward and the reverse. So this is what every process will receive. One process will be spawned with GCA something, and the other process will be spawned with SRR something else. And the data structure that is going to be passed to the process is a tuple that contains a value that we can call sample ID, and then a path. In our case, the reads, and it's plural because it's a list of forward and reverse. This is the input, And so we can make use of this input. How? With the command that is fastp minus I, lowercase I is the forward pair, so dollar reads 0, minus capital I dollar reads bracket 1. So this is the second element of the list. And then we can save the output files. So we use a sample ID, that is the part before the underscore R, as an identifier. So sample ID underscore field R1 fastqgz. Now be careful that, of course, you want to avoid collisions. So if I create a sample, an output file that has the same name of the input file, it's not going to work well. So you can create a directory if you want. So you can mkdir filtered, or in this case, I just add a suffix like field, but we will see something more about this. So first pair output, second pair of output. We enable the detection of the adapter for the paired end. Minus W is the number of cores. So at the moment, just specify task.cpus. We have a configuration file that is going to take care of this. And we will talk about this maybe later. And we also want to save the report in JSON format of the process. So in this file, fastp will store some metrics of the files before and after the filtering, and this can be used later by multi-QC to make a nice report. And the point is that it's also allowing us to see that a process can emit multiple channels as output. So we have a first channel that we will call reads, that is also a tuple, so ID and paths. And JSON channel. In this case, I just discard the value. So instead of creating a tuple, I just emit the file alone. Fastp. Now, all the programs that you will see here are examples. So if you're familiar with other programs, the key point is that all the programs will need somehow to receive input files and will produce output files. Of course, if you don't know fastp, it's not a big deal. Just assume that it's going to do some filtering. And but if you're interested in knowing more, the documentation of fastp is impressive, and fastp itself is a really complete toolkit to perform filtering with different criteria. And it's also relatively efficient. And I particularly like that it's also saving this JSON file that is easy to parse, and it's also natively supported by multi-QC. Now, are there any questions about this first process? Because this is the first process we created. So as you can see, input column as many lines as the input channels are, and they need to be modeled after what we are going to receive. So if our reads channel is a tuple, we need to specify a tuple and collect the respective values here. Otherwise, either we need to manipulate the reads channel or to adapt the process. We'll see again this maybe later, but the idea is that this is what we receive. There is a queue of tuples where there is the sample ID and then the reads, and every process will be spawned with one of these items. And if we have the capacity, all the processes will be spawned in parallel. Here we define the output, and it's very important because if the process fails to create the output files, if fastp will not create these files, the process will fail. If here I write instead of fastq fq.gz, but then I tell the process that it's going to expect fastq.gz, it will fail because fastp correctly creates the files that they request, but then the process monitor, if you want, is not going to find what we told him to expect. So a common failure of a process is because there is some mismatch from what the process actually creates and what the process expects here. Any questions so far?
Could I just ask, I'm a little unclear about the workflow section at the bottom and how that interacts with the emit bits. Is that sort of an overview so it's easier to write? I've not seen it before.
So let's have a look at the assembly part, just to make the vanilla example first. Assembly is going to take as input the usual tuple, value, and paths. Okay, but it's going to emit a single output, again, sample ID, and then the contigs. If we want to fish the assembly output, it's simply assembly.out. So .out as a added to a process is going to take the output channel of that process. So assembly.out is the output of assembly. It's convenient when you have multiple outputs to label them with something that is user friendly. So for example, reads for the reads, or field reads if you want to be more explicit, and JSON or report, you can call it whatever you want, but with this comma emit column string, you put a label to that channel. And this means that when you have a process like fastp that emits multiple channels, you can say, okay, well, assembly is going to need fastp.out.reads. We need the reads for fastp, not JSON.
Is that making sense?
Yeah, kind of, slowly. So the stuff in the brackets at the bottom there, that's all the input for each of the processes.
Yes. So if you had multiple inputs, you would just comma delimit them if you one after the other. It's very much like feeding it into any function or method call in a program. So fastp is like a program, a function that you've written, and you're just giving it the input in there. But you don't give it the input. What you're specifying here is not the explicit input. It doesn't know about that, but you're sort of going back to the analogy of the Linux pipes. You're just setting up the framework that you have fastp, you have the assembly tool, and you're saying from the fastp has a specified this read output, and you're just connecting it to the assembly thing. And so the assembly, so that's your, yeah, so the output. So as what you'll see when Andrea actually runs it is that they will just run as soon as there's data from fastp in the queue, the assembly thing will just hoover that up and start running. And if there's space to run multiple processes, it'll do that.
Now, before we go on, we need to now address one important part. So if there are questions about the syntax that we just saw, let me know now.
Andrea, I got a couple of related questions, but it's more about the process. So if a process fails, does the workflow exit or it gets stuck in that particular process? And the related question is, can we make the processes independent so they can finish some even if some fail?
These are very good questions. Let me pause for a while. So the reason for a process to fail are multiple. So a process can fail because the program crashes, let's say returns non-zero, for example. Something happens, or even the program does not exist, because this is what we are going to talk about now. because now we just assume that Nextflow somewhere finds fastp, but we don't have fastp at the moment. So if we run the workflow as it is, it's going to fail because of that. So if it fails because of a, let's say, coding error, because of course we must use tools that exist. If it fails because we've specified the wrong parameters, I say -1 instead of -R1, for example, it's one kind of failure. So it's a bug and we need to fix that. But sometimes it fails because sometimes failing means that there are no errors, so every programs happily finish their execution, but they don't produce the expected output. And sometimes this is because there is no output to produce. So most of the programs in Unix, they will create an empty file. And so this means that the process will not fail. But suppose that your program will only write a contigs file if there are contigs, and you supply really bad reads and they do not assemble and they don't produce a config, that's also a reason to fail. So your question is really good. If you want to make your process a bit more fault tolerant, you can specify that the output is optional. That means that if the output is produced, it will be added to the queue of the output channel. If not, no. And this means that if you have 100 of isolates sequenced, and some of them didn't sequence, maybe you have just 20 reads on some of them, this is not a problem. Because if you say that the output of a process is optional, those samples, let's say, will be terminated at that point. They will not continue because they will not make it into the output channel. Does this make sense to you?
Yeah, thank you very much. Yes, I was wondering all the multiple ways that a process could fail, and it would be dependent on whether you have an output or not actually. So it definitely answers the question that I got. Thank you so much.
When we will run our first script, you will, because the point is, I don't think that anyone can write a Nextflow process that doesn't fail at the beginning. So learning how to deal with failure is really important. And let me mention another nice thing of Nextflow. Sometimes the process, you have an HPC, and so you need to send jobs to a queue, and maybe you specify that for the assembly you need, I don't know, 32 gigabytes of RAM. Suppose that one of your assemblies make a very strange and complex De Broglie graph that's going to not to fit into the 32 gigs RAM. The job will fail. Nextflow will hear that it's going that the failure was caused by Slurm terminating the job for excessive resources request, and you can handle that. In the configuration file, you can say if the job fails because of that, resubmit the job with twice the memory. And this is something that is also good of Nextflow. You can make your workflow tolerant of some kind of errors without requiring always 2 terabytes of RAM for every job that is an overkill, right? Okay.
Yeah, so basically to sum, it depends on what you want to do. Failures are different things. In some cases, you might, if a single sample fails, you might just want to terminate the entire process and just say, nope, we have to make sure it's all or nothing. You might want to be more permissive. Nextflow sort of allows you to do one or the other, rerun in certain circumstances and so on. It's really dependent on what you're trying to do, but the platform does allow you to kind of make those decisions and encode those into your workflows.
Brilliant, thank you both.
So just to make an example that is not yet in the repository, but I will add it. So at the moment I have fastp installed, so I will delay for a bit the dependency thing. I have Nextflow installed in my local machine, and I simplify the workflow. So the same assembly 0, assembly 1, I just removed the assembly and proca processes. I don't remember. I just kept the fastp. So we'll just execute fastp, And at the end, I will just view the JSON, for example, output channel of FastP. Because that's a way to inspect, to build up slowly our workflow, is to understand what they are producing and how they can run. So let me.
Did we need another break? It was there in the program break at 4:20.
Let me know.
How do people feel about that? With we had a break a bit earlier, but I don't know if people need a bit of rest to unplug. That's actually drawing the session to a close, actually, for the practical. You're happy to press on, right, Andrea? I want to show some more.
Yeah, sure.
So what we can do is we'll take some, Andrea will push on for a bit more up until we cross over to Rob's section, but it's effectively going to be working through the tutorial, which is up anyway, going to each of those assembly 0.nf files and so on. So that material you already have. And we'll keep going till 10 to 5, where Rob will come and join us and talk about some other things regarding Nextflow. So if you want to take a break now until 10 to 5, that's fine.
Absolutely.
There is a point of that. Like, I appreciate, like, there's a lot to digest, and there's no point trying to just grind more. If you need a rest, that's perfectly fine.
Absolutely.
But if you're still keen, we'll press on a bit more and do a little bit more.
So to make everyone, let's say, relieved and not guilty of taking a well-deserved break, first, you already saw a lot, and just running these small scripts is enabling a whole world of Nextflow. So first, congrats for keeping up so far. The questions were really good, and the feedback was great. I will publish on YouTube the walkthrough for all the steps, so you don't need to to struggle any longer. And I encourage you to take a break. If you want, I'm here, so you can still ask questions or see what we're doing, but there is really no need for this because everything will be released online.
Can I suggest something, or do you have something you want to show us? I mean, you've run a thing already. You just run the FastP.
Yes. So in this case, and I will put this in the repository as 0B or something like that. Basically, I simplified the Nextflow, the assembly one workflow. Now the workflow is one process, FastP reads, and then we inspect one of the two output channels it created. Now, as you can see, here the FastP ran for 3 samples, for all the 3 samples, and then this is the output of view for the JSON channel. The first thing that I want to point out is that, as I mentioned earlier, by default, you will see a work directory with all the intermediate files. Now, I run it, the Nextflow in this directory for the first time, so I only have 3 subdirectories because I had 3 files processed. So the last one was T7, that was E7 something. So if I see inside work, there is E7 and see something. So this is where I take the information from. And Nextflow is symbolically linking the input files. As you can see, there are the output files created, and 2 are the FASTQ files, and 1 is the JSON file. And the JSON file is here, is what I visualize with show me the output channel called JSON from FASTP, from the process FASTP. So the next step would be, in case I can, well, I introduce another thing before we move along. Sometimes, especially when you create a workflow, I filter the reads, I'm happy, I don't want to modify the process. I can use -resume to say, retry the workflow, but if something was cached, if something is already present in the work directory, use the intermediate file, don't recalculate everything. So if I run it with resume, I didn't change anything. I didn't change the script, I didn't change the input files. And so the process finished instantly. But if, for example, here I say, show me the reads channel, if I run the workflow again with resume, what happens is that Nextflow will see that FASTP didn't change, so that will be cached, and then we'll just execute this FASTP out reads view. And again, don't worry about this. Everything will be in the repository because it was planned to add ad hoc scripts. So now you can see that something changed, and the magic is here. The input channel for FASTP is the new channel from pairs that we created. So is how Nextflow represents a paired end data set. Value and then paths. And we kept the very same structure for the output reads. And this is a good way to make a module that filter reads, because you can skip it without changing the logic of the workflow. So if you say, I want to disable the filtering, you don't need to create a new assembly module, because it's going to receive the same structure, the same format of reads. But for the JSON report, I didn't specify a tuple. So I stripped the value and I just kept the file. So if I watch fastp.out.json, it's a list of JSON files. While fastp.out.reads is a channel of tuples where you have the sample ID and then the list of files, exactly as it was created. The only difference is that now the files are the filtered one. And I appreciate that this is quite complicated, because it is, but just arriving at this point makes everything possible, because we covered all the syntax needed to create the whole workflow. Because with assembly 0, we saw how collect works. Now we saw how a process works, and we just need to create more processes. What I do is simply like copy a process, paste, and change the name, change the input, change the output. It's very easy to scale up when you get the logic of the single process. But the logic of the single process, it is complicated.
Is that making sense for people? I'm curious if you can hop onto the voice and have a chat. Hopefully people are still pressing on. It is, as Andrea says, if you go back to the assembly 1 NF and you look what's the difference between the FASTP version, the assembly version, the Procker version of the processes, it is very much, yeah, it is effectively the same thing over and over again. It's input coming in, it's modified, there's output coming out, there's certain streams of input, certain streams of output. And then effectively you take this module and you just keep chucking on as many as you want. The critical thing I think Andrea is trying to demonstrate, which is a major stumbling block for people, is that you kind of go, oh, okay, this is easy. I have one set of reads that goes into one program, and then there's one output, and then that goes into another program, and there's one output, and then there's one output, and there's one output, and you just have this daisy chain. That's conceptually quite easy to understand. But then you have this problem of, oh, I've done 100 of things, and now I need to collate some result. I need to collate some values, some genotyping result, or some a set of assemblies, and that's what he's showing with the JSON files, just exactly this thing of the dot collect. You want to collate it together, you want to collapse it into one single set of inputs that is run by a program once. So I'm trying to think of a good example. If people have used something like, if people have ever built a, have done read mapping before, and they've done variant calling, and they've done something like they want to make a phylogenetic tree or something like that, you run hundreds of individual read mappings of your data, of each set of data to a reference. You do it one after the other over and over again, and then you merge all of that into one single set of data to feed into some sort of phylogenetic inference program. This is a very common pattern where you explode out and do a whole bunch of samples, and then you sort of dovetail them back into each other. So this dot collecting is very important, and it can work. It can be that, I mean, what about the other way? What if you just wanted to feed the reads into a whole bunch of programs at once? I think Nextflow DSL2 basically allows you to reuse the channels. So you have the FASTB filtered reads, and let's say you want to do an assembly, but then you want to read map it, you want to do something else with it. You can just keep using that same, at this step here with the contigs, you put it into QUAS, you put it into annotated, you do some genotyping on it or some gene searching on it. You can just take that channel and paste it in whatever. So this, the critical thing is understanding this component input output of this little black box that's running the process. And then how do I burst it out so that, it runs 100 of them at once, on one for each point of data, and then how do I merge that back in for a final aggregation of some sort. Once you get this thing of the flows and the channels, it's really just that's it. That's the basic mechanics, and it's just remixing on that. And then we probably spend a lot of time trying to make it tolerant of all sorts of nonsense user input more than anything else after that point, once you sort of sketch that out. So, we've already had the example, okay, I write this thing, I wanted to use short reads, but then I put a command, a parameter, params.long, and if someone says params.long, okay, I'm going to treat the reads as long and I'm going to do something else, all of that sort of thing. Hopefully that makes sense. What we're trying to sort of cover there. It's a different way of thinking, really, embedded in that's implemented in this.
So this has been really great. Can I ask a quick question?
Yep,
Of course.
It's about the modularization. I noticed on the GitHub page, the pipeline has been split into multiple scripts in different modules, and whether you could talk a bit about practicalities and the advantage of doing that rather than having it in one huge script.
Sure. The advantage is mainly one, that you can reuse the same file multiple times. So you can create, let me introduce this. So if you arrive at the assembly 4, the pipeline is as we designed it. So I go to the workflow, is FASTB, assembly, abricate, proca, quost, abricate, and multi-QC. So the pipeline is finished. Everything is in a single big script, big file. With assembly 5, I guess, now we only have the workflow, and they adopted the common practice of giving the process names all caps names, very bashy. And where are these processes? Here is where the magic happens. So you can include the processes from an external file. So usually you have a modules subdirectory, and then I have a qc.nf, and you just omit the extension here. And in that, from that QC, I import FASTB and multi-QC. So strictly speaking, you can import everything. You can just put star and import all the modules, but it's not a good practice. So it's better to just list all the modules that you need to import. And this makes so that if I create a new pipeline that also requires FastP to begin with, I just take the modules QC and copy this line, and FastP is sorted. I don't need to copy and paste it.
Could you show us the workflow then, what that looks like, the workflow? So it's much the same as before. The capitalization is a stylistic thing. It doesn't make an effect to the Nextflow doesn't care about this. This is just for us for readability.
Yes.
But the interesting thing here is because it's in a separate module now, you can just make as many different versions of this specific file that specifies the workflow. And you can mix and match it as much as you like. You can get modules, and Rob's going to talk about this. You can get modules from your friends, from clone their copy their module files, their NF files, which they've painstakingly made perfect and work. And you can just be like, okay, I'm just going to import them and just write my own workflow, and it's 10 lines and I'm done. Assuming you understand the inputs and outputs. You don't really care what happens internally. It just gets you the result you want. Does that make sense?
Yeah, well, that's really cool. Thanks.
Yeah. So I think the key thing is to look at the import syntax in that script.
When I said that sometimes the errors are unforgiving, if you put a column instead of a semicolon here, probably you're not going to really understand the error until you double check what you did. But just in the last minutes, I wanted to talk a bit about the dependencies. Now, in this repository, there is a deps subdirectory with some README, and also in the tutorial, there is a gathering the tools page. So I'm not telling you something that you will not be left out. There are some typos, but I will fix them. The approach here was to create an environment with the tools that I needed, because it's a small workflow. So I created an environment with, well, I created like this. So Mamba creates -n de novo, FastP, Chauville, Unicycler. Well, here there are more than I used because I'm still working on something else. And then I created the environment. This command, if I run it in June, is going to produce a different environment because there are different versions. So here I just said that I want MultiQC later than 1.9. But even if you pin a specific version, the dependencies will change. So after creating this environment locally, I did a conda env export, and I created a YAML file. That this is the actual recipe that will clone my environment in a different machine. If you just are interested in conda, this is already a good thing. If you have an environment in your machine, you can share it with a friend that has the same operating system, because as Anna said, Linux and Mac are not having the very same packages. So, but this is the recipe to create an environment that contains FastP, Chauville, and all the other tools that I need. And from that, I have both a definition file for Singularity that, as Nabil said, just installs a mini conda and then create the environment and then activate it for me. And I have a Docker file. As you can see, takes the environment file, creates the environment, and exports it. And what I did in the end is that I pushed the Docker container to Docker Hub. And in the important Nextflow config file, I created a profile. I created a profile Docker saying, well, just take this image from the Docker Hub. In this case, I didn't tag the version, which you should probably do. And this is how it can work without doing any installation. But for you, and also in the handout is written how to do so, the simplest way that also overcomes the problems with Docker Hub limits is to create, manually create the environment, activate it, and then run Nextflow from within that environment. For developing a pipeline is an easy way to work. Otherwise, you can also specify in each process which conda package to download, and then Nextflow will take care of downloading the package. But this can have some other limitations. For example, when you have a cluster with no internet access, it's going to slow down your workflow. So it's something that you need to customize with your needs. I tend to prefer Singularity for this kind of pipelines, because then I can use it in VMs and in the cluster. But again, there are many possibilities. The take-home message here is that you can take care of the dependencies and tell via the configuration file how to find them, either from Conda, Docker, or Singularity, or with -profile, as in the screencast was shown. You can use the one that better fits the current system. So congratulations again for surviving so far.